Sample problem 3.1. A cyclist confidently rides off a building's edge with a horizontal velocity of 5 meters per second. Find the bicycle's position or distance x sub f from the cliff's edge and velocity v after 0.3 second. So we have here the cyclist, then it rides off the edge of a building with a horizontal velocity. So V naught is horizontal along the x or purely along the x. That's why alpha naught or the angle is equal to 0. And it is positive V naught because in our sign convention to the right is positive. Now the question is to find xf and v velocity at t equals 0.3 second. And also position r. So when position is asked, we are actually looking for r. So letter A, solving for position r at t equals 0.3 second. Here we will use equation for r. R is equal to square root of xf squared plus yf squared. So it is clear that we still need to solve for xf and yf in order to obtain r, using now equation 3.5 to obtain xf. Solving for xf, or the final horizontal position, at t equals 0.3 second, using (3.5). We have xf is equal to v naught cosine alpha o t. So we substitute. V naught is 5 meters per second. So V naught is there, given, just substitute. Cosine alpha naught is 0. Time is 0.3 second. Using your calculator, you should obtain a value of 1.5 for the unit. Second over second cancels, leaving meter, which is a correct unit for position. And then we solve for yf using equation 3.7. Solving for yf, final position at t equals 0.3 second, using 3.7. So yf is equal to v naught sine alpha naught times t. plus 1/2 g t squared. We substitute the value. V naught is 5 meters per second. However, sine 0 is actually 0. So I'm just substituting, but we know that this first term, because sine 0 is 0, this first term is 0. All right. And for the rest, the second term plus 1/2 g is negative 9.8 meters per second squared times at 0.3 second squared. Executing 1/2 times negative 9.8 times 0.3 squared. Using your calculator, you should get a value of negative 0.441 meter. Y final. Note that YF is negative because at 0.3 second, the bicycle with its rider is below the starting point. Now that we have XF and YF, we can solve for R. We substitute. R is equal to XF is 1.5 meter square plus YF is 0, that's negative 0.441 meter squared. Using your calculator, you should obtain an answer of 1.56 meters. Distance XF from the cliff's edge. So we have already solved that. The answer for XF is 1.5 meters. Last, we now solve for velocity V after 0.3 second. Solving for velocity V after 0.3 s. So from what we've derived, V is square root of VFX squared plus VFY squared. And for the direction tangent alpha is VFY over VFX. It is obvious that we still need to get VFX and VFY in order to get our V. So we use our equation 3.4, the one we derived, to get VFX. Final velocity along the X at 0.3 second. So equation 3.4 is VFX is equal to V naught cosine alpha naught. So substitute the given V naught is 5 meters per second times our alpha naught is 0. Cosine 0 is 1. So the answer is 5 meters per second. And then using to get our VFY 3.6 to solve to obtain VFY at 0.3 second. We have equation 3.6. VFY is equal to GT plus V naught sine alpha naught. We substitute G is negative 9.8 meters per second squared times time 0.3 second plus V naught 5 meters per second sine 0. Sine 0 is again 0. So we are left with the first term multiplying negative 9.8 times 0.3. You should get an answer of negative 2.94 for the unit second over second squared gives you second. So the unit is meters per second for VFY or 2.94 meters per second downward. Now that we have VFX and VFY, we can solve for V. V is square root of VFX squared plus VFY squared. So solving for the magnitude of V, V square root of VFX squared is the 5 meters per second squared plus VFY squared negative 2.94 meters per second squared. Using your calculator, you should obtain a value of 5.8 meters per second as the magnitude of our velocity. Now for the direction, VFX is to the right and VFY is downward. So if we are to make a sketch, rough sketch, VFX is to the right and VFY VFX and VFY. It's a rough sketch. So we will be getting the angle. I'm using alpha. Alpha as the direction, the angle. Okay, so tangent tangent alpha is opposite. Our angle is VF sub y over VF sub x. And the value for this is VF sub y is 2, I'm just writing the magnitude, 94 over, or you can write the negative sign, over 5 meters per second. Okay, so arc tangent, so execute your calculator, shift tangent of negative 2.94 over 5. You should get an answer of negative 30.46 degrees. Or this means that below the horizontal. Or you may say, or 30.46 degrees south of east. South of east, below the horizontal. So our final answer, thus V is equal to 5.8 meters per second, 30.46 degrees south of east. Sample problem 3.2. You throw a basketball with an optimal initial speed of V naught equals 7 meters per second at an angle alpha naught equals 60 degrees from the horizontal. Find letter A, the basketball's position and velocity 1.15 seconds after its release. Letter B, find the time when the basketball reaches the highest point. Letter C, what is the maximum height the ball could reach? Letter D, find the horizontal range covered by the ball. So here we have the sketch. The ball is thrown 60 degrees, which is equal to square root of xf squared plus yf squared. Again, we see that we need to solve for xf and yf in order to get r. So solving for xf using 3.5. xf is equal to v naught cosine alpha naught times time. We have at t equals 1.15 15 seconds. So V naught here, initial velocity 7 meters per second times cosine alpha naught is 60 degrees. Time 1.15 seconds. You should get an answer when you execute 7 times cosine 60 times 1.15. You should get 4.025 meters. For the unit, second over second cancels. So we have meters. That's for XF. Now we solve for YF. Solving for YF using 3.7. We have YF is equal to V naught sine alpha naught times time plus 1/2 g t squared. Substituting the given V naught 7 meters per second sine alpha naught sine 60 degrees at time 1.15 seconds plus 1/2 g negative 9.8 meters per second squared at time 1.15 seconds square. Using your calculator, execute the first term 7 times sine 60 times 1.15. Then plus open parenthesis 0.5 times negative 9.8 times 1.15 squared close parenthesis equals. You should get an answer of 0.491 meter. We can now solve for R since we have obtained XF and YF. So R now, solving for R. R is square root of XFX squared. XF is 4.025 meters square. Here's XF. YF 0.491 meter. 0.491 meter square. Using your calculator, execute this one. Using your calculator, you should get an answer of 4.05 meters. Solving now for the velocity v after 1.15 seconds. Using again equation 3.9 and 3.10. Equation 3.9 is solving for v. We have v is equal to square root of, we have v is equal to square root of velocity final along x squared plus velocity final along y squared at 1.15 seconds after releasing the ball. Again, we need to find for Vf sub x and Vf sub y in order to solve for V. Solving for Vf sub x using 3.4 equation. We have Vf sub x is equal to V naught cosine alpha naught. VO is 7 meters per second and cosine alpha naught is 60 degrees. Using your calculator, execute this. You should get an answer of 3.5 meters per second. Solving now for Vf sub y using 3.6. We have Vf sub y is equal to gt plus V naught sine alpha sub 0. Substitute the values. G is negative 9.8 meters per second squared. At time 1.15 seconds plus V naught 7 meters per second sine 60 degrees. Using your calculator, negative 9.8 times 1.15 plus open parenthesis 7 times sine 60 close parenthesis equals, you should get an answer of negative 5.2 meters per second. Or we can say that 5.2 meters per second downward. So after 1.15 seconds, the ball is traveling to the right and going down. So to solve for our magnitude V here, we simply substitute now, solving for V, since we now have Vfx and Vfy. V is square root of Vfx squared. So that's 3.5 meters per second squared plus Vfy squared. That's negative 5.2 meters per second squared. Vfx and Vfy. Using your calculator, square root of 3.5 squared plus negative 5.2 squared, you should get an answer of 6.27 meters per second as the magnitude of the velocity. For the direction, again, we sketch the components of the velocity. We have positive 3.5 and negative 5.2 along the y. So positive VFX, rough sketch, to the right because positive VFX. Rough sketch for VFY is going down. It's negative 5.2. So going down. Rough sketch there. The rough sketch. Of course, this is longer because it's 5 and VFX is just 3.5. But that's a rough sketch. So now our angle all right. Our angle now is this is our resultant vector V. Alpha to indicate the direction. So we have this is a going down VFY. Tangent alpha is equal to opposite of angle alpha is opposite side is VFY over adjacent side is VFX. So we substitute VFY is negative 5.2 meters per second over VFX is 3.5 meters per second. All right, so that's arc tangent. Arc tangent. Shift tangent in your calculator. Open parenthesis negative 5.2 divided by 3.5 equals, you should get an answer of 56.06 degrees. Or this is negative, means below the horizontal. Or (56.06 south degrees south of east. So we can say that V at 1.15 seconds after release, V is 6.27 meters per second, 56.06 degrees south of east. We will now solve for the time for the ball to reach the highest point. Letter B. Time for the basketball to reach the highest point. At the highest point, we have V final, okay, along the y is equal to 0. And then we use equation 3.6. We have there VFY is equal to GT plus V naught sine alpha naught. So VFY at highest point is 0. So 0 is equal to GT plus V naught sine alpha naught. Here we are solving for time, and we have G, we have the V naught, and we have the alpha naught. So we can use this equation by transferring the second term on the right to the left. It becomes negative, since that's positive, negative V naught sine alpha naught equals GT. We want the time, so we can divide the entire equation by G. Divide by G, divide by G. G over G, that's 1. So we now have our equation. T equals negative V naught sine alpha naught over G. Substituting the given, we have negative V naught is 7 meters per second sine 60 degrees over G is negative 9.8 meters per second squared. Using your calculator, this is the T for the ball to reach the highest point. You should get a value of 0.62 second. Now letter C, to solve for the maximum height reached by the ball, we use equation 3.7. Basketballs maximum height. Or we have, this is Y final when VF y is 0. And of course, we have and at the highest point. All right, so using equation 3.7 to solve for this maximum height. Using 3.7. We have YF is equal to V naught sine alpha times 10 sine alpha naught times time plus 1/2 GT squared. Substitute now V naught 7 meters per second. Angle is 60 degrees. And at time, the one we obtained, time at the highest point, 0.62 0.62 second. Plus, we continue, second term, 1/2. G is negative 9.8 meters per second squared. Times, this is the time at highest point, 0.62 second square. Using your calculator, execute the first term. 7 times sine 60 times 0.62 plus open parentheses 0.5 times negative 9.8 times 0.62 square close parentheses equals. You should get a value of 1.87 meters. So this is the maximum height reached by the ball. And lastly, letter D, solving for the range R. Solving for the range R. We have the equation 3.11. R is equal to V naught cosine alpha naught times T total time in air. From the point where it was released vertically, going back to that point. So is equal to, so going back to that same height but different x. V naught is 7 meters per second. Cosine times cosine, 60 degrees. And 2, T total is time to reach the highest point times 2. So 2 times time to reach the highest point. Yes. Using your calculator, 7 times cosine 60 times 2 times 0.62. You should get an answer of 4.34 meters for the range.